Hi everyone, we are going to talk about the metric system. Many thanks to Cam 105 Tripod for this beautiful base unit list. So really talking about metrics, at the very foundation of it, there are base units that can be then made into derived units, and we use prefixes. So you're thinking base units and then you're thinking prefixes. Let's look at the base units first. There are 7 base units. And you could Google this, you can look anywhere to find this. So length, for example, is meter, and the symbol is M. Just a little bit of backstory on this. It was in the 1960s that scientists got together and said, hey, we need to have common language, common measurements. And so these are the agreed upon common measurements. It is System International. It happened in France, and our nickname for it is the metric system. Here is the one that trips students up. It's mass. Mass, the base unit, is kilogram. And what's tricky about that is they included a prefix, kilo, on it. If students are going to miss a question on base units, it's this. They'll put gram instead of kilogram. Now, a derived unit is when you combine any of these base units. For example, if I take area. Area is length times width, and I'm going to do meters on this. So if I go length times width, which would be meter for the unit times meter, that gives me meter squared. That is considered a derived unit because we brought 2 base units together, length and length, meter, meter, to get meter squared. One of our most common derived units is density. Density equals mass over volume, and that unit would be grams over centimeters cubed. So that's going to be a derived unit. Now, prefixes. Let me scroll down. Here are examples of prefixes. Now, how you read this, and you can Google this, like anywhere on the internet, and it's going to be presented the same way. If you have one of these charts, this is what I would write on it. I would do above these items, the prefixes, write the number 1. Okay, so I'd write the number 1. Write the number 1. This is saying if I have one of these items, if I have 1 gigabyte, if I have, 1 millimeter, if I have 1 decisecond, if I have 1 micrometer, if I have one of any of these, how does that relate to the base 1, a meter? So I'm going to use meters, okay, as my base unit. We could take any of these prefixes and add them to those base units. So I could have a, let's come here to centi. I could have a centisecond, I could have a centimole, I could have a centimeter. You could take any of these and attach them to those 7 base units. But I'm just going to use meter. Let's just use meter. Okay, so if I have 1 kilometer, that's telling me I have 1,000 meters. So over here on meaning, I'd write the word, to help you, meter. So how many meters are related to this 1 unit, this 1 prefix over here? If I have 1 decimeter, that is 1/10 of a meter. So think of a meter stick. A decimeter is 1/10, and that's why it's 10 to the minus 1. A centimeter, 1 centimeter. So a centimeter is about the size of my finger, okay? The width of my finger, that's close to a centimeter. If I have 1 centimeter, that is 100th, or 10 to the minus 2 of a meter, Now, if you're going to write this for dimensional analysis, let me show you how you could do this 2 ways. And I'm going to show you the way that I like to do it. We can write it based on this. 1 kilometer is equivalent to 1,000 meters. Great, that's easy. Where it gets tricky is down here and all these fractions. From deci down, these are all a fraction of a meter. So let's do millimeter. 1 millimeter, okay, 1 millimeter is 1 times 10 to the minus 3 meters. It's a thousandth of a meter. Now, here's the honest truth. I personally don't like fractions. So another way that you can write this, and sometimes it's just totally clicks and makes students for the first time understand the metric system. I do, for these fractions down here, how many of those prefixes fit into a meter. So there are 1,000 millimeters in 1 meter, and that's easier than doing the fraction. If I'm doing nanometers, there are 1 billion. 1 times 10 to the 9 nanometers fit in 1 meter. Now, if I'm going to write it like this, I would say one tiny little nanometer is 1 billionth, 1 times 10 to the minus 9 of a meters. 1 tiny little billionth of a meter is 1 nanometer. So you can look at it both ways. I personally like doing the how much fits into a meter from here on down. It just clicks with my brain. Some students love that, and others are just fine doing the fraction. So whichever works for you, they are equivalent. They're equivalent. So you can use either one. All right, metric.